Hi, I'm Jasprit. So, our today's topic is gravitation. I hope you are in good health and spirit. So, we will proceed with our topic here. Humans recently realized what is gravitation is. So, in the beginning, Greek philosophers thought that the planet and the star were the part of the God realm and they followed the natural motion. They didn't realize the some forces involved. Yeah, they just think the Earth is at the center and every planet revolve around it. But the later, the astronomers like the Galileo and the Brahe discovered that the Earth and the other planets revolve around the Sun in the fixed orbits. And the Kepler showed that these fixed orbits are nothing else. These are the elliptical orbits, not the circular one. So the question arises here, why is this happening? Why the Earth and the other planets revolve around the Sun in the particular orbit? Yeah, the question here is why this is happening, and the answer is given by the Sir Isaac Newton. He discovered the force of gravitation when he saw a falling apple while he was thinking about the force of the nature. Whatever really happened is Newton just realized that some kind of force must be acting on the falling object like an apple, otherwise they wouldn't start moving from the rest. He realized that the moon would fly away from the earth in the straight line tangent to its orbit. Yeah, if some force was not causing its fall toward the earth, that means the moon would fly away in the tangent line. That is, it will deviate it from its path, but it continuously revolving around the earth in the particular orbit. So the question is why it is happening. Newton called this force as gravity, or the force of gravitation. Hence he determined the in each and every object there is a force, and that force is known as the gravitational force of attraction. Using the idea of the gravitation, he was able to explain the astronomical observations of the Kepler, the work of the Galileo, Brahe, Kepler. Newton proved once for that the Earth wasn't at the center of the solar system. The Earth, along with the other planets, revolve around the Sun in the particular orbit. So, with all this history of the gravity and the gravitational forces, here we have some questions. That questions are like why we are standing firmly on the ground, why the freely fall body moves downwards, why the planet orbit around the sun in the particular path, why do not they changes their orbit, why the rain falls downward, why the snow falls downward, but is responsible for the tides. Yeah, which force is responsible, which force is holding the environment on the earth, and the answers of this question lies in one and only one word, that is the gravitation. Yeah, so the word gravitation and the gravitational force, this force is just a simple force which is binding us towards the earth. It is particularly the force of attraction between the two bodies, which is having some masses and there is some distance between them. Actually, the gravity is a particular case of the gravitation, as a gravitation and the force of gravitation is just the force between the two body which is having some masses and the distance apart. Yeah, but the gravity is also the particular case of gravitation in which the earth's gravitational pull is known as gravity. That means in which the two bodies, one body is earth, then the force of attraction between them is known as the gravity. Yeah, so now we will derive the formula for the gravitational force. Now the Newton said this force is directly proportional to the product of mass of the two bodies. Yeah, if we have the bodies, body m1 having the mass m2 and body having the mass m2, and there is a distance between them like r or d. Yeah, so Newton stated that this force is directly proportional to the product of the masses of the two body, and this force is inversely proportional to the square of a distance between them. When I am combining these two proportionalities, I am getting this. The force is directly proportional to m1 and m2 and inversely proportional to the square of a distance between them. When I'm removing this proportionality, I just have to add some proportionality constant. Yeah, that constant is known as the gravitational constant here. So the force of gravitation is equals to G, where G is a universal gravitational constant. Why it is known as universal? Because its value remains constant. It is true for every type of a body. And this Newton's gravity law is also known as universal law of gravitation. Why? But because it is true for each and every kind of a body having any type of a mass or any distance between them. Yeah. So force of gravitation is equals to G m1 m2 upon r square. Now this is G. What is this G? This G is universal gravitational constant. How we are defining it? Numerically, it is equals to the force of gravitation between the two masses of a unit weight and having a unit distance between them. That means the force of gravitation among the unit masses and having the unit distance between them. That means 1 square, 1 into 1, that means force. This gravitational constant is equals to gravitational force when the mass of the two bodies is unit and the distance between them is also a unit. So the value of a G is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. So now we can see that how a minor change in the masses can affect the force of gravitation between them. Yeah, we have the masses like initially we have the masses of mass m and capital M, small and capital M, having the distance between them like d. So the force of attraction between them is G capital M small m by d square. But after some time I just change the mass of my one object and I'll take it as like 2m. I just doubled the mass of it, and another one is same as that of previous mass. So the distance between them is d. So the force of gravitation become what? G 2m into m by d square. This become G m upon d square. What is this? What is this? This is the previous force. Yeah, this is the previous force. The force becomes 2 times of the previous force. That means a little change in the masses or the distance between the object can affect the force of gravitation. Now we can also see that if there is a gravitation force between the, as I have stated that it is a universal force. Yeah, universal force of attraction. Is there any force between the balls of 1 kgs and they are like 1 meter apart or 2 meter apart? Yeah, what is the gravitational force between them? The force of gravitation would become G into 1 by just like 2. It's 2. It is just like 6.67 into 10 raised to the power minus 11 just divided by 2. When we just saw this force, it is coming out into 10 raised to the power minus 11. Yeah, that means the force of attraction is very negligible. That means these two stones will not show any motion. Why this is so? The force of attraction is very, very small. So now we can say that is there any the force of attraction between the ball and the earth when we are throwing the ball in the upward direction? Yes, there is. The force of attraction is present there. But we can see that only the stone is moving in the downward direction. Why the earth is not moving in the upward direction? What is the reason behind it? The earth is not accelerating and the only stone is accelerating. The reason is that the mass of the earth is very, very large than the mass of the stone. Yeah. So as we know that the force of attraction between the two bodies is same. The force of attraction applied by the earth on the stone is same as that of the force of attraction applied by the stone on the earth. That means the forces of attraction, the force of the attraction experienced by the both the bodies is same. that the only reason behind it, the mass of the earth is very large as compared to the mass of the earth. That means the acceleration, as we know that the force is only about the mass into acceleration, so the acceleration produced in the earth is very very small, as that the force upon mass is gives us the acceleration. As the mass of the earth is very large, so the acceleration produced in the earth is very 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 small than the acceleration produced in the stones. Yeah, so this is why only the stone accelerated toward the earth, not the earth accelerated toward the stone. Now we will do some question related to this topic. I hope you have understand this topic. The force of gravitation between the two bodies varies, as the force of gravitational formula is G m, capital M upon r square. So it varies, like the force of gravitation is inversely proportional to the square of a distance between the two bodies. So the option C is the correct answer. The gravitational force between the two bodies is F. If the masses of the both bodies is half without changing the distance between them, what would be the force of gravitation? So as we know, the force of gravitation is what? G capital M small n upon r square. What we do, the masses of the both bodies become half. That means the m become half of m, yeah, and small m become half of small m. So what will be the force? G m dash small m dash upon r square. This will be G half of m half of small m upon r square. It will become what? It will become here. Force is equals to 1 by 4 gm small m upon r square. That means it means f dash become 1/4 of the previous force. Yeah, it become 1/4 of the previous force. So the next question is, which of the following is evident to show that there must be the force acting on the earth which is directed toward the sun? The deviation of a freely falling body toward the earth? No. The revolution of the earth around the sun, the phenomena of a day-night, the apparent motion of the sun around the earth? No. That means the revolution of the earth around the sun is our answer. The value of the gravitational constant depends upon nothing, as it is a universal constant. It depends upon nothing. It is a universal constant. The law of gravitation gives the gravitational force between the earth and the point masses, or the two charged body, or the earth and the sun, or the two bodies having some masses. That means the law of gravitation is a universal law of gravitation. That means it is true for any kind of a body which is having some masses and some distance between them. So our option B is the correct answer. So here is a summary. Basically, the difference between the gravity and the gravitation is the gravity is the particular case of the gravitational force. Yeah. So gravitation is one of the fundamental four forces which exert the force on our body, and which is known as the weight. And weight is simply the mass and the acceleration due to gravity. So gravity is providing the necessary force which is keeping the planet in the elliptical orbit around the sun. That force is known as a centripetal force. Yeah. So as the gravitation is decreased by the inverse square law, that means the force of gravitation is inversely proportional to the square of a distance between the two bodies, and it is also responsible for the tides in the ocean, and it is also govern the trajectories of the planets. So thank you. I hope you get this chapter, you get this topic completely. Thank you so much.